Hey everyone. If you're a senior architect who spends your days building on AWS, you know exactly what I'm talking about. There's this constant tension you have to deal with. So in this explainer, we're going to build out a conceptual framework for modern API and integration patterns that tackles that tension head-on. Let's get right into it.
You know, it really all comes back to this one question, doesn't it? Pretty much every single decision we make as system designers boils down to this fundamental trade-off. Are we going to optimize for right now, for the absolute fastest response for that one user? Or are we building for the future, for a system that can take a punch, handle whatever load gets thrown at it, and scale out gracefully?
And this is what we call the architect's dilemma. On one hand, you've got your users demanding responsiveness. They click a button, they expect something to happen instantly. But on the other hand, you need resilience. Your system has to be able to absorb huge spikes in traffic, recover from failures, and evolve over time without completely falling apart. And a lot of the time, these two goals are pulling in completely opposite directions.
So how do we solve this? How do we get both? Well, it all comes down to one core principle: decoupling. And the number one tool in our toolbox to make that happen is by making a very conscious, very deliberate choice between synchronous and asynchronous communication for every single interaction inside our system.
Honestly, at its core, this idea is as simple as this slide makes it look. Think about it like this. Synchronous communication is basically a phone call. You dial the number, you have to wait for them to pick up, you have your conversation, and you can't really do anything else until you hang up. You're blocked. Asynchronous, though, that's like firing off a text message. You send it, and then you're free. You can go on with your day, the response will get there when it gets there, and you'll deal with it then.
And this, right here, is the holy grail. By choosing the right tool for the job, knowing when to make the phone call and when to send the text message, we achieve what's called loose coupling. This just means our services don't need to know all the nitty-gritty details about how other services work. They can be scaled up or down, updated, and even fail all on their own, without causing a domino effect that takes down the entire system. This is really the bedrock of any modern resilient architecture.
Okay, enough with the theory, right? Let's get practical and see what this actually looks like in a super common AWS pattern. We're going to start by tracing a simple, synchronous API call, our phone call.
So this is a classic pattern, and for a really good reason. A user makes a request from their browser or a mobile app. First thing it does is hit Amazon API Gateway, which is kind of like our secure front door, our managed entry point. API Gateway then triggers a Lambda function. This is where our business logic lives. Maybe it's fetching a user's profile. That Lambda function then goes and queries a database, gets the data it needs, and sends it all the way back up the chain to the user. It's fast, it's direct, and everything is happening in real time.
And this pattern is absolutely perfect for things like reading data. But it creates a new problem. What if that Lambda function also needs to do some other stuff? Like send a welcome email, or update a search index, or maybe generate a PDF report. Suddenly, the user's just sitting there, staring at a spinner, waiting for all of that to finish. And that's work that can wait.
And this is where things get really cool. This is where we introduce the power of events, our text messages. Instead of cramming all that work into one Lambda function and making the user wait, we can just announce that something happened. We can emit an event and let other parts of our system react to it whenever they're ready.
So check out how this changes our flow. The Lambda function still does the important stuff like writing to the database, but then it immediately fires off an event, something like user created, to a service like Amazon EventBridge. As soon as that event is sent, it returns a success message back to the user. The user's experience is now lightning fast, while all our other services can pick up that user-created event and handle the email, the search index, and the report all in the background.
But this powerful new asynchronous world comes with its own scary monster: back pressure. Think about it. What happens if you get a sudden flood? Let's say 10,000 new users sign up in 1 minute. Whoa, your Lambda can probably handle that. It can fire off 10,000 events almost instantly. But can your poor little email service handle that kind of load all at once? Probably not. It's going to get totally overwhelmed, it'll start dropping requests, and things will break. That's back pressure.
And this is exactly why managed services on AWS are, frankly, a lifesaver. A service like Amazon's Simple Queue Service, or SQS, acts as a giant shock absorber for your system. So instead of sending events directly to that email service, we send them to an SQS queue. The queue can easily absorb that massive spike of messages, and our email service can then pull messages from that queue at its own steady, manageable pace. It's completely protected from being overwhelmed.
Okay, so let's look at the main tools in our asynchronous toolbox. You've got SQS, which is your durable buffer, your reliable waiting line. It's perfect for decoupling two components. Then there's SNS, or Simple Notification Service. Think of this as your megaphone. You publish one message and it gets blasted out to many different subscribers at once. And then you have EventBridge, which is like the central nervous system or post office for your application. It's an event bus that lets you route all kinds of events from many different sources to many different targets. It's incredibly powerful.
All right, so we've covered a ton of ground. Let's try to boil all this down into 3 foundational patterns that really every single AWS architect should have in their back pocket.
First up, you've got your bread and butter, the synchronous request/response pattern for those direct, gotta-have-it-now API calls. Second, you have your workhorse, asynchronous queue-based processing using SQS, which lets you buffer work and process it reliably, even at massive scale. And third, you've got the conductor of the orchestra, event-driven fan-out and routing, using SNS or EventBridge to coordinate really complex workflows between lots of different services.
And just like that, we've come full circle. By really mastering these patterns, by knowing when to make the phone call, when to send the buffered text message, and when to use the broadcast announcement, you can finally solve the architect's dilemma. You can build systems that give users that instant, snappy responsiveness they demand, while also having the deep, robust resilience that the business absolutely requires.
So you've done it. Your system is this beautiful, loosely coupled collection of services. It's responsive and it's resilient. But, and you know there's always a but, this new architecture creates a whole new challenge. When a single click from a user can now trigger a dozen different asynchronous workflows, how in the world do you see what's actually going on under the hood? Your system is decoupled, but is it truly observable? Well, that's a whole other can of worms for another day.